Welcome to this place value video, primarily aimed for Year 6 students dealing with rounding numbers. Now, I'm going to be honest, I take a strange approach to rounding numbers. I'm going to try and extend it so that it works all the way through. What do we mean by rounding numbers? Well, sometimes we need to do things in our heads that we can't actually do. So, if I was to try and do the number 23 times 46, that actually might be rather too complicated. I might not actually need the value, I might not need the real answer to 23 times 46. I might just need an approximation, a number close to. And so what we tend to do is we call it rounding by thinking of 23 as, well, that's pretty close to 20, and 46 is pretty close to 50, and now hopefully we can do 20 times 50 a lot easier than we can do 23 times 46. So rounding helps us take a best guess. But I seem to have jumped a bit of a step. How did I manage to say that 23 is closer to 20 and 46 is closer to 50? Well, I think, fingers crossed, that would seem pretty obvious. If I have the number 23, what are the numbers closest to it if we were to round in tens? Because this is 23, that's the same as 2 tens and 3 units. So let's look at the idea of rounding to the nearest 10. Well, 20, what's the number lower than 20 that's closer to 10? Well, it's 20, and the number bigger than that would be 30. And hopefully we would realise that 23 is actually much closer to 20 than it is to 30. So we say that we can round 23 to become the number 20. What about the number 46? Well, 46, what's the number bigger than 46 to the nearest 10? Well, that's 50, and the lowest would be 40. So 46 fits between 40 and 50, and hopefully we will realise that 46 is closer to 50 than it is to 40. So we say that 46 can round to 50. There we go. So 46 rounds to 50, and 20 is closer to 23. Let's try another example. 87 times 42. Well, I don't want the real answer. I want an approximation. I want a best guess. Well, let's look at the number 87. 87. Well, that's between 80 and 90 if we were looking at the nearest 10, because we've got 80, which is 8 tens. So that's closer. So that's between 80 and 90. Here is the number 42. Well, that's between 40 and 50 if we look at our numbers. And so now we just got to realise, well, what is it closest to? Well, I think 87 is closer to 90 and 42 is closer to 40. So we would now write that as 90 times 40 if we wanted our best guess. And although beyond the scope of this video, we should be able to work out 90 times 40 much easier. What about if numbers become a bit bigger? What if I had 547 times 36? Wow, that gets a bit complicated. Well, maybe not. Let's look at the 547. I've got 547. That's 5 hundreds. So if we look at numbers in terms of hundreds, what is the number lower than 547 that's still in the hundred? Well, 500. And bigger, 600. And what about the number 36? Well, this is only our tens, so that fits between 30 and 40. Which numbers is it closest to? So 547. Well, I think that's closer to 500, and 36 is closer to 40. So we'd have 500 times 40 as our guess answer, as our best guess. Now that's how lots of people teach rounding numbers. I like to think of it in a slightly different way. Look at the number 547. That, in place value, is in our hundreds column, our tens column, and our units column. So we have our hundredths column, our tens column, and our units column. Now sadly, it's not always the case that we would want to round this number to the nearest 100. Going back, if I've got the number 547 and I look, well, okay, that's between 500 and 600, then what I'm actually doing there is rounding to the nearest 100. But what if I wanted to round it to the nearest 10? Well, the 500 isn't as important as it could be previously. I want to now round to the nearest 10, and sometimes this gets a little confusing. Well, what I do is I put a circle around the number that I'm rounding to. So if I'm rounding to the nearest 10, I put a circle around the number that's in the tens column. And I look at this number here, this 7. Now, 7 is closer to 10 than it is to 0. And what we tend to do is if a number is closer to 10, we make the number in the circle 1 more, because that's what it's going to do. This number is really 47. If we ignore the 5, it's 47. And what number is 47 closest to? Well, it's closest to 50. And the 5, because it's part of the hundreds and isn't really being thought of at the moment, stays where it is. And so our number of 547 rounds to 550. Wow. What about the number 636? Well, imagine I want to round it to the nearest 10. This is my tens column. I'm going to put a circle around my tens column, and I'm going to look at this number here and decide, well, does it change my 3? Well, yeah, of course it does, because this is now 36. And what number is 36 closest to? It's closest to 40. The 6 stays where it is, and so my rounded number becomes 640. I'll keep going with examples. Let's get more complicated. Let's do 832. Again, I still want to round to the nearest 10. This is my tens column. I'm going to put a circle around the number that I'm going to round to. And we look at this. Well, this is now 32. And what number is 32 closest to? Well, hopefully we're all happy to think that that's closest to 30. So 32 is closer to 30, and there is my 8. So 832 is closer to 830 if I'm rounding to my tens. Wow! Now maybe a bit of a trick question. 735. Still, we're going to round to our tens column. There's my tens column. Put a circle around it. 35. What number is 35 closest to? Because actually it's smack bang in the middle, isn't it? Let's look. Let's write the numbers out from 30 to 39. 30, 31, 32, 33, 34, 35, 36, 37, 38, and 39. How many numbers are there? Let's just check. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. There we go. So there's 10 numbers. And if I split them in half, that means I'll have 5 numbers on one side and 5 numbers on the other. So 1, 2, 3, 4, 5 numbers. There we go. 1, 2, 3, 4, 5 numbers. What do I now notice? I notice that 35 fits in the bigger half. So what we now suggest, or what we tend to use, is that 35 we think of as closer to 40. So the number becomes 740. All right? So anything with a 5 we tend to think of in maths as rounding up. Right? Anything lower than 5 stays the same. What do you notice? Look. So let's do another example. 394. To the nearest 10, put a circle around my nearest 10, and now think of this as 94. That gets to 90, and the 3 stays as it is. So, interesting. This 2 did not change the 3. The 4 did not change the 9. But the 5 changed the 3 into a 4. I'll do one more example. 676. Still to the nearest 10. Circle. Think of this number now as 76. What happens? 76 is closer to 80. So the 6 changes the 7 into an 8. The 6 stays the same. What happens to this number here? It becomes a 0. What happens to this number here? It becomes a 0. What happens to this number here? It becomes a 0. What happens to this number here? It becomes a 0. So we actually seem to be picking up a bit of a pattern. This screen's looking a bit messy. Let's clear it up and try another one. Wow, complicated example. This one's now got 4 digits, 2,768. We'll do one more example where we round to the nearest tens, but we don't always round to the nearest 10. So there is my nearest 10, it's the 6. Let's look at this. That's 68, it becomes 70. The 7 stays as it is, and we now notice the 2 stays as it is. This number here, look, the 8 was bigger than 5. It's 5 or more, so what did we notice? The 8 changed the 6 into a 7. The other numbers stayed exactly the same, and the 8 turned into a 0. Or, as I like to think about it, nothing. The 8 became big fat nothing. Right? Nothing. Let's see what happens if we try and change this number to the nearest 100. Let's do it again. 2, 7, 6, 8. We're going to do it to the nearest 100. So we circle the 7. I could think of this number here as 768. Well, what's that closest to in terms of hundreds? Is that number there closer to 700 or is it closer to 800? Because if you think about it, 768 falls between 700 and 800. Well, which one's it closer to? It's closer to 800. So there's 800 and the 2 stays the same. So 2,768 is closer to 2,800. But look, once again, the number after the 7, is it a 5 or more? Yes. So what does it happen to have done? It's made the 7 into an 8. It's made it one more. What do you notice about the number before the 2? It stayed the same. And what do you notice about the other numbers? They've become zeros. I'm beginning to like this. There's a bit of a pattern going on here. 3,420, I don't know, 9. Let's see what happens here. So I'm going to round to the nearest 100. I'm going to put a circle here. And I'm now just going to look at the number after the 4. It's a number 2. Well, what did we decide? Well, we know that the numbers 0 to 4 don't change anything. This is a number 2, so that 4 doesn't change. It stays as a 4. What did we see about the numbers before the 4? They tended to stay the same. And what did we notice about the numbers after the circled number? They become zeros. And look, we've now rounded 3,429 to 3,400. And that's true. Let's think of this number again as 429. Which number is that closest to? 400 or 500? Yeah, it's 400. So 3,429 is closer to 3,400. Ooh. Let's change. More examples. 4,568 or 4,568. Let's round this to the nearest 10. Let's go back and see what we can do. Let's round it to the nearest 10. This time it's a 6. So let's look at the number directly after. Remember, 0 to 4 stays the same. If it's 5 to 9, it makes the circle number 1 bigger. Yep, 8 means that that 6 is going to get bigger. So the 6 becomes a 7. The numbers beforehand stay the same on the whole. And the 8, if you remember, becomes nothing. So 4,568 is closer, if we're rounding to the nearest 10, to 4,570. And let's just check, is 68 closer to 70? It sure is, governor. Shall we take the same number and round to the nearest 100? Yep, 4,568, but this time to the nearest 100. Let's put a circle around the number that is in my hundreds column, and we look at the one number afterwards. Does the 6 change the 5? Yeah, it's bigger than 5, or it's 5 or more. So the 6 changes the 5 into a 6, the 4 stays as it is, and what do the rest of the numbers become? They become zeros. Checking, is 568 closer to 600? Of course it is. And lastly, let's just change this, let's check it, and let's see whether 4,568 to the nearest thousands. Put a circle around the thousands. Look at the number afterwards. Does the 5 change the 4? Yes, of course it does. The 5 will make the 4 one bigger. And what happens to all of the rest of the numbers? They become zeros. Now I keep choosing numbers that are rounding, but let's just check one number that hopefully will be slightly different. 4,372. Let's round this to the nearest 100. Does the 7 change the 3? Yes, it does. What happens to these numbers? They become zeros, and the 4 stays the same. So pretty much the same as example, but what happens if we round to the nearest 1,000? We're rounding to the nearest 1,000. Put a circle around the 4 because that's in my thousands column. So look at the number afterwards. Does the 3 change the 4? No. Remember, if it's 0 to 4, it doesn't change the number. If it's 5 to 9, it does change the number. So the 3 doesn't change the number, the 4 stays the same, the rest of the numbers all become 0, and there we go. Now there is a small trick, because maths, remember, is a big, fat trick. What happens if I have the number 6,798 and I want to round this to the nearest 10? Well, what do? We put a circle around here. We look at the 8. Does the 8 change the 9? Yes, it does. But what happens? Well, the 9 becomes a 10. Ooh, well, how? We're not going to write that number doesn't become 6, 7, 10, 0, does it? Because that would just be stupid. That doesn't make sense at all. So what happens? Well, the 9 becomes a 10, but it gives one of those numbers to the 7. I tend to think of it as 79 here. I think of the number as 79. So if the 9 gets bigger, then the 79 becomes 80. This number here becomes a 0, and the 6 stays as it is. Wow, that was a bit freaky. Let's just do one more example. 4, 9, 6, 7. And let's round this to the nearest 100. So, we look at the number afterwards. Is it a 5 or more? Yes. So it's going to change that number. But the 9 becomes a 10. So let's think of this number now as 49. Add the 6 makes the 49 bigger to become 50. And what happens to the rest of the numbers? They become zeros. Woo! Now, I may by this point be confusing. Some of you will get it, some of you won't. You'll cover it again later on in secondary school. But let's just do one last example for those who are still with me. And we'll round this one to the nearest 10,000. Where's the nearest 10,000? Well, that's my units. That's my hundreds. There's my thousands. There's my 10,000s. So we're going to round it to my nearest 10,000. Put a circle around there. Does the 6 change the 4? Yes, it does. The 4 becomes a 5. The 2 stays as it is, and the rest of the numbers become zeros. Now, later on in secondary school, what happens is we start thinking of things in terms of significant figures and decimal places. Not going to get too excited with decimal places, but as an extension, we'll do one decimal number. 36.748. What if I wanted to round it to the nearest tenth? Well, where is my tenths? Well, that's there. Now, the rules work in exactly the same way. Look at the number after the circle number. Does the 4 change the 7? No. So the 7 stays as it is. The numbers before the 7, on the whole, stay exactly the same. And the numbers after become zeros. But what do we know about decimal numbers ending in zeros? Any number that ends in a lot of zeros after decimal can have those numbers not written. So that now becomes 36.7. In year 7, what we've just done is rounded that to 1 decimal place. But as I say, that's probably beyond the scope of this video. Well, hopefully we've done a little bit about rounding numbers. I look forward to seeing you on the next video.